Greetings to one and all present here. My name is Viren Varma, and I was a mentee at the Google Summer of Code under Faro Consortium, under mentors Sebastian Jordan Montano and Gordana Rakik. My project was to redesign graph libraries and integrate new algorithms to it. A little bit about me. So I did my bachelor's in technology in mechanical engineering from NIT Karnataka Surathkal. I previously interned as a data analyst at Wells Fargo, and I've published 2 research papers in NMIT Con and CentCon. So I'll be speaking about my project at Faro in the Google Summer of Code 2023. So our key deliverables were to redesign the Graph Algorithms API to make it easier to access and incorporate new algorithms like A star and longest algorithm for DAG and DCG. I was also tasked to complete the graph layouts library that was previously built and exploring new algorithms for this particular library. So starting out with my work, I coded out the A-star algorithm where I wrote specific test cases and I used distra as the heuristic function to calculate the heuristic value. I followed standard API practices and I took a reference from other algorithms that were coded out in the same library. Here's a small example of a test code as well as the kind of tests I wrote for A-star algorithm, and all of them work perfectly. My next task was to code out the longest path in directed acyclic graph and directed cyclic graph. So for this, I used a variation of topological sort algorithm for DAG and a variation of Bellman-Ford for DCG to code out these 2 particular algorithms. Coming to the next part of my project, which was redesign graph algorithms test package. So basically, I had to shift all the fixtures that were already created for these tests from instance side to the class side and classify them on the basis of their weight, their cycle, the existence of a cycle in a graph and their complexity. And I classified into these 6 classes, and most of them I redesigned this library this way. I also added a graph visualization feature or a functionality for it, which is something like this. So for each particular class, you can just inspect the particular class and see each visualization for each fixture. So that's how it works. Coming to the next part, yeah, so we also made a demo of this entire process and upload it on YouTube, so you can see it over there. Here's the link for it. I'll forward it to Jordan, and maybe he can forward it to everyone else at ASUG. The next part was working on completing the graph layouts library, where I changed the graph structure to add accessors for better node traversal, as well as I added a feature for code visualization as well. I fixed all the bugs that were there in the algorithm as well as in the test cases, and I wrote new specific test cases that would catch any new bug that's created for any new layout algorithms that will be created. Yeah, so here's a small demo of how it all worked. So this is basically the visualization of a particular graph, and over here is the particular class over here. So this is how that particular visualization works for each of the particular graph layout, and these are very say coordinate centric. So if there's a variation in one particular coordinate, that will be shown in the visualization. This is again, that was the box representation. This is the circle node representation. Next part was solving this problem, which was updating traversing nodes. And initially, the node traversal in fine node was done linearly with a time complexity of O of n, and we explored a lot of PRs looking for a better optimized search using binary search method to bring it down to log n, but none of them worked properly. And we eventually went with mapping each of the node labels with the nodes in a dictionary and bringing the time complexity down to O of 1. So here's a small example for it. Here's the node dictionary where the entire mapping goes, and this gets built at the build time when the entire graph is being built. So eliminating of all errors. There's still a lot of scope for future work left. So for example, we still plan to create a separate external package for graph layouts and graph algorithms for a common graph structure, and this graph structure can be accessed by both packages externally, and I think this will be a more optimized way. I think that's the end of my presentation. Thank you so much, everyone. Thank you.